Hello, this is Fahad, and this week we'll talk about industrial boiler sequence of operation. How do they function, and what is the most common sequence of operation? So first thing we have to think about is actually we have to talk about is the PLC, which is programmable logic control. These controls are mostly can be programmable, and we will hear this terminology a lot, which is PLC, which means the thinking process of the control. So what do we usually do? It does pre-ignition check. So before we turn on the control, or I mean before we turn on the boiler, we have to always do a pre-check. So first of all, it will check that all the valves are closed and ready position. It will check the high and limit that they are closed and the circuit is made, and also will check the airflow, I mean the air damper, and make sure that is in the open position, and that is done to purge the system. So imagine if you have a boiler, I mean probably you did that in residential, that you turn on the system. If there's fire already in the chamber, the system will not turn on. So it does that as a safety measure. So it does a pre-check before we start the firing process. And the first thing it does is the purging process. It's a pre-purge, and I will talk about that. So that's a pre-purge. The pre-purge cycle is meant to empty. It's a given time where the blower motor will turn on by itself to push in air inside the chamber, and also if we have a induced draft, we can pull air to empty the chamber from any residual smokes or flue pipes or gases, or even to cool off the boiler a little bit before we start the firing again. So again, it's predetermined based on the size of the chamber, and to remove any vapor combustible remains inside the boiler. The time is based on the size of the furnace, and also is dictated by the insurance company to make sure that once we pump fuel there, it will go along with the sequence of operation. It's not going to just combust. Probably you have noticed that the chamber gets really hot, and sometimes if it's hot enough, we as soon as we pump some fuel in there, it will it will just fire up, and that's not really desirable. So again, it's a good way to know that the chamber is ready, and when we start our firing procedure, it's not going to ignite by itself, and that's the purpose of the pre-purging. Again, it's very involved based on the chamber. If you look at the air coming out and the air coming in, you want to make sure this space is empty. So the volume here has to be completely empty, and as we mix in, as we put in air inside the chamber, it will mix up with whatever is there. So the chamber should be the flow rate here should be calculated to empty the entire chamber. Second step is lighting a pilot. On a lot of those big industrial boilers, we have a pilot. The pilot is a way to ensure that we have actual flame inside the chamber before we pump in the main fuel. So it has its own line, and again, the pilot could be a different gas. So you can have an oil burner, but you have a gas pilot, and vice versa. So it could be a little bit different, but you want to have ignition always turned on. Third step is proving that there is flame inside the chamber. So once we light the pilot, we get a flame sensor that will tell us how big of a fire is there and if there is flame or not. If there is no signal, the system will shut down. So again, we saw last week few things about different kind of fuel and what sensors goes with what. So flame rods usually go with gas, photocells with fuel oil, and both IR and UV can be used for oil or gas. And again, that's because they have different color, and those are reacts with they react with flame light, and they call it optical. So lighting the main flame. So first we we lit the flame, we activated the flame, we proved that there is a flame, and now we are trying to light the main flame. So after you light the pilot, you will go and make sure there's flame. So we first do the pilot, then we open up the main gas valve. So we have a pilot already. So if we have this boiler, we have a flame, that's the pilot, then we have the main flame, that's the main flame. So once we know that there's actual flame here for the pilot that's been proven, we can open up the gas valve and start firing the main flame inside the boiler. And that's why sometimes we have more than one flame detector. Once the main flame is proven, we shut off the pilot valve because there is no need for it anymore. And at the end we have only the main flame inside the boiler, and we can maintain operation. If the main flame is not proven, the system will completely shut down, and it will give us an option of restarting or diagnosing what is the problem and why the pilot did not come. After the main flame is proven, we go into autopilot. The whole thing will run, and we will scan the system using pressure controls. So for big boilers, we are looking for steam, so we monitor our steam pressure, and probably you have covered that in the power plant because it's mostly about big boilers. So once we activate the flame is running. The main output that we want from the boiler is the steam. So we can monitor the system by steam pressure, and there we have high steam, high pressure steam, and low pressure steam, and based on that we can keep the flame going or stop it. So this is an example of an industrial boiler. If you can notice here, this is a fire tubes where the fire and flue gases goes through the tubes, and the water is washed away and running through tubes. These are the main components, and you can see it looks like a bigger gun burner over here, and these are my relief valves, and we have two just for redundancy and safety. Pressure controls that tells you if we have high or low pressure, and this is where the flue pipe gases go through the pipes to heat the pipes and go outside to the exhaust. And let me see if they have, no, it doesn't show here the controls. I mean, this is my control over here, and this is completely automatic, and it should tell you what fuel is running. So they look the same, but some of them are actually, if you look here, that's my flame proving signal. After we finish, let's say we want to shut off the boiler and we want to turn it off, we do a post purge. So just like we did a pre-purge, there's also a post purge. In the post purge process, we try to cool the boiler or furnace. Actually it's a boiler because we're making steam. We cool the boiler and let go of any remaining fuel that's unburnt. And also it will clean the combustion chamber from any residuals of again flue pipe gases or residual fuel in there. So these are the 6 main steps for industrial boilers control. So the combustion control system, our autopilot or computer, will do the following. It will regulate the fuel based on the pressure. It can increase or decrease. It will also regulate the air supply. There's a damper that will go back and forth depending on the oxygen contents inside the air. We adjust the fuel to air ratio, and this can be done automatically. It will also adjust the draft. So all these things that we used to do manually in the residential boilers now are done using a control system. So you can see why is it more involved, and they're more controlled. And these are all automated. The air supply is controlled by a damper. The air fuel ratio is also controlled by a damper, and a regulator which will open and close the valve for the fuel and also control a damper as well. Fuel can be regulated by pressure if it's gas, or by the quantity that being pumped, regulated by a nozzle. This can be also regulated by pressure for oil. pressure for oil or gas. Uh, so to provide the required steam, we usually start with the low fire, so we do not go with the main full-blown fire that we need. We ramp up into the fire, so we start with low flame and build up to that until we reach the steam that we need, steam pressure required. And also we would like to improve the cycling. We don't want to turn the system up and down, on and off all the time. No, we want to be ramped up until we get to the main flame. So start and operation in here. So it's a good way to start with low, and that's why we have more means to regulate the fuel and air that's coming inside the chamber. Okay, I'll stop now and I will make the second video.